In our last lesson of the unit, we are going to take a look at 3 more formulas. The first formula we're going to look at is the most complicated, so it actually gets easier throughout this lesson. Our first formula is power reducing. So we've got sine squared, and the reason it's power reducing is because we are going to change it from a function with a square to a function with a power of 1. So we're reducing that power. So we're going to change our sine squared into our sine squared formula. So we'll have 1 minus cosine of 2x all over 2. And then we'll multiply by the power reducing formula for cosine, 1 plus cosine of 2x all over 2. Multiplying our two expressions together, in the numerator we have conjugates, so we've got 1. The plus cosine 2x and the minus cosine 2x cancel, and negative cosine 2x times positive cosine 2x gives us negative cosine squared of 2x. Now you're not actually going to multiply those 2's together because that's part of the cosine formula. You have cosine of 2x times cosine of 2x, so it's cosine squared. And then in the denominator, the 2 times 2 is 4. Notice our power isn't actually reduced. We still end up with a cosine squared. So we are going to use that power reducing formula one more time. And we have to be careful on this one because now we're going to end up with a complex fraction. So we're going to do 1 minus 1 plus, so I'm replacing the cosine squared with the power reducing formula, and this time x isn't just x, it's 2x, so that's why I've got that 2x in parentheses right here, and then all over 4. So we're going to start in the numerator trying to simplify that by subtraction, so I'll need a common denominator to do that, so I'm going to turn my 1 into 2 over 2, so I'm getting it with a common denominator in the numerator. And then I'll subtract my 1 plus cosine of 4x all over 2 all over 4. Once I do that, I can subtract in the numerator. Be sure you distribute that subtraction sign to the cosine as well as your 1. All over 2 all over 4. Subtracting in my numerator, I have 1 minus the cosine of 4x. And then when we've got this complex fraction, that 4 is going to go in the denominator as multiplication. We've got another example. We're going to be using the power reducing formulas twice again, because this time we have cosine to the 4th, which is the same as cosine squared times cosine squared. So we're going to get a fairly similar answer to what we saw on the first one. So starting by substituting in those cosine squared values as 1 plus cosine of 2x all over 2, and then we're going to multiply it by itself. So in the numerator, because we don't have conjugates, it doesn't simplify quite as nicely as it did when we had sine times cosine. We're going to get 1 plus cosine of 2x plus cosine of 2x plus cosine squared of 2x all over that 2 times 2, or 4. So combining our like terms in the numerator, we have 1 plus 2 cosine of 2x plus cosine squared of 2x, which means we're going to be using that power reducing formula again because we still have a squared. So substituting in for that cosine squared, just like we did on the last example, we've got 1 plus cosine of 2, and again we're replacing x with 2x all over 2, all over 4, getting a common denominator with each of the terms in the numerator. I'm going to multiply them by 2 over 2, so our 1 turns into 2 over 2. Our 2 cosine 2x turns into 4 cosine 2x all over 2, plus the 1 plus cosine of 4x all over 2 all over 4. All right, so in the numerator, we're going to add our numerators. So we have 2 plus 4 times the cosine of 2x plus 1 plus the cosine of 4x all over 2. And this is our numerator, so we still have it all over 4. Again, combining like terms in the numerator, that 2 plus 1 gives us a 3. So we have 3 plus 4 times the cosine of 2x plus the cosine of 4x. And this would be all over 2, but I'm going to move that 4 into the denominator as multiplication because we're multiplying by the reciprocal, or multiplying by 1/4. If you wanted to, you could do that butterfly method and split each of these up as their own fraction and simplify that middle one, but I would accept this answer as well.